TheTechRabbit here again. So now we're going to go back to the Rust app skeleton and add some library usage routines and a few utilities. So if those that don't remember what this is or haven't watched the previous video, this is like a loose re-implementation of parts of the Amos Basic Pro program structure and startup code. And it's a warning, it's not object oriented because it was built 35 years ago. And also I'm not going to go into the basic, repeat the basic create building steps, or which I already described in a previous video, so now we'll just jump directly into it. So I'll take a little side jump there. This is the, you remember the workspace project, and then in Microsoft Code you can actually create a workspace, and the idea with the workspace is the workspace you can define that it can contain more than one folder. So I just thought I'd actually show the workspace file and what it looks like. So if you create this kind of a, you can also do it from within inside Microsoft Code, but let's say you can also manually create this, and then here so that it's in this directory now, or this directory here. And then that means that you want to have open the folders, or the folder, your current folder, which will be this one, and then you want to have a secondary folder, which is in my case this is another project structure or folder structure for the OS hypervisor. So I just thought I'd show that. So instead of jumping between different folders in Microsoft Code, you can actually create a kind of like a top level workspace where you can actually include all the folders you wanted to open. So then we have here, for example, we have the TheTechRabbit Basic, and then we have the TheTechRabbit OS hypervisor folders. Oh, now that we want to be able to add or use some additional functions that are implemented in the flat library structure, then you have to actually declare them in the code that you want to use them, so that you use this syntax use, and then you say what library, and then what function. And then I just listen. So we have the open library. We're going to have an open library, closed library, find task, and write utilities. And I will have a little bit of look at those in detail a little bit later. But when you're going to use these functions from a library, then you have to actually declare with the use state. So here we look at the function main, which is the starting point of the application, and then here we have define that it will actually return a result, and it will either return an empty tuple, or then it will box up the standard error message. And here we have the open library, one of the open library function calls. So this open library supports the usage of the name of the library as a string, and then you can actually even enter this if you want to have a specific version of the library, and then you can enter the version, and then it returns this OK or error. So if it's OK, then it just prints out that it was successful in opening the library, and if not, then it prints out the error, and then it also returns the error string through main to the top level calling function. And I've added those that were with us in the previous video. Then we had this SP buffer structure, so I pulled it over, and then we've only activated right now the SP workbench boolean value. And basically it says that if it's been started from the workbench or not. So, and then I've added this, so here we declare a task, and we use the find task function to find the executing task, which is this one. This is a little bit faked, but it does, from the interface perspective, it does what it's supposed to do. So then you have if it's okay, then it will return the task, and then if there's an error, then it will exit with the error. And when it continues, then it populates the SP buffer, SP workbench with the task definition, whether the CLI is being used or not. Also implemented a very simple write function with error return, and this write function, as it's customized, can actually identify if the standard output can't be used. Then it will actually return an error, which is a little bit different from the other console write features the one has, and it's in line with the interface definition of the legacy environment. And then finally we have close library, and here you give the name of the library that you want to close, and if it successfully closed, then it will return empty, and otherwise it will return an error. So, for example, if you try and close a library that has already been opened, or it otherwise fails, or when the library gets a little bit larger, then it will actually need to do cascade closing of substructures, and maybe it will actually fail there, and then need to be able to capture the error situation. So now, to implement some common functionality you would like to include in this, that you've noticed that Rust uses the definition of using defined macros, and this is actually the syntax how you create your own macros. So you say hash macro export, and then macro rules, and then you give it a name, and then in the parentheses there, you define the function block, and then it actually contains your code. So in this case, I'm actually made a function that is common and implemented as a macro that gets the information about the metadata for the crate. And actually, we should look at the that one. Yeah, you can look at all of them have the same. So basically, there's functions available to get the name, version, edition, and what did I have support for? It was package name, version, author, and description. I added there. That's the support. So it will read it from each crate's definition, so that you have a common interface to cargo information. And then I also created a macro which will implement the library state information, and this is if you've followed my previous video on references, then we tried to create a global variable, and it was actually difficult because it was complaining that it wasn't thread safe. So this is the actual syntax or method you use to create a global variable which is thread safe, and you have to use caps for the name of the global variable due to the Rust syntax rules. So I created a macro where you're able to set a library to be open, set it to be closed, and query if the library is open or not. So when you want to use a macro in another part of the system, then you need to declare what macro you want to use. You say common crate info, and this is the library state info, and then you actually put this here. So that actually inserts the macro code into this code section, and then I actually added the tests for them here also, so you have where it's testing both failure cases and non-failure cases. And here for the same for the state info tests. And then here we have the actual the one that I referred to previous to the task struct, which only has this, currently only has this parameter. So in exec we have the open library implementation, and it looks at the library name that you've requested, and then it'll execute a code specific to that library, where it actually goes out and it goes and gets the version information. And if you are requesting a specific version, then it'll tell you if you succeeded in getting the if that specific library version is available right now, or it's some other one. And then it'll give an error if the library has already been opened, and then if it hasn't been opened, it sets it to open. And then it returns the information, and in addition to that, it returns the version of the library, the crate that it was able to, or the library that it was able to open. So pretty simple emulation of the existing implementation's intentions, even if not 100%. And then it's for all the different libraries, DOS, exec, blah blah blah. And then it returns an error also if there's a library name that doesn't exist. And then you have closed library. Basically it does the opposite. It checks if it isn't open, then it gives an error, and otherwise it closes it and then returns okay. And that's the same for all the libraries that are supported. And then there's a bunch of tests also, so you can see in what variations of different calls work and don't work. And then we have this very simple find task. Yeah, and then it's also that if you then try to give it a task name, it'll actually give you an error and say that it can only find itself, because this is just to emulate the case where the library call wants to find it actually only wants to find itself. So in this specific case. And then it's also that it's we say that it's what did I have to think? Yeah, exactly. We say that the CLI is true by default. Because the original libraries, they run on Amiga, and Amiga makes a distinction between if you're running it on a workbench or not. And when you're running it on Windows, it kind of maybe doesn't matter. We'll see if we add more logic, if it will become critical to know if you started it from the command prompt or from a shortcut icon. But currently it doesn't make any difference. And there we have the DOS library, and same thing that we import the crate info, library state info, and then the standard IO self-write. And this was the biggest difference, that this specific syntax here, it can actually react to the fact that that for one or the other reason standard out is not available or will not work. So that's why I made this small wrapper for it. So, and then this here syntax is more in line with the base write call that's in the original system. So it hasn't got very many fancy features at all. It's just basically you give it an ASCII string and then it prints it out. So anyway, this was a summary of the additions done to the skeleton. So we've added rudimentary library open close, utility functions write task, and then to find out the task status. And it also shows you how you actually go ahead and add your own macros to Rust. and how they should be used, and then how you use some flat functions. You know, like in this case where we have multiple libraries, and each library would like to use functions from other libraries. So anyway, hope you enjoyed this one. I'll upload this code so you can go pick it up as an example and do whatever you want with it. And I'll see you in the next one.